And now let's go on to talk about empty sets. If a set has no elements, it is called an empty set or a null set. For example, if all the students in a class are taller than 120 centimeters, then we can define an empty set, let's say G, as the students in the class whose heights are less than 120 centimeters. Since there are no members in the set G, we say that the set G is an empty set. The following are some more examples of empty sets: the prime numbers from 8 to 10, days of the week that start with the letter L, and integers that lie between 10 and 11. Universal sets. Sometimes it is necessary to classify a set as belonging to a larger or more inclusive set. For example, the set of capital cities in the Caribbean can be said to belong to the set of capital cities throughout the whole world. So universal sets are not unique for a given set, but in all cases, members of a universal set must contain all members of the set we are making reference to. The universal set can be represented by a capital U or this symbol. Sometimes we may be asked to construct a universal set for another given set. For example, if we are given the set rectangles, squares, trapezoids, and kites, we may get the universal set quadrilaterals. Or if we are given the set 2, 3, 5, 7, and 11, we may get the universal set prime numbers. Now let's look at set builder notation. Set builder notation is a simple and convenient way of describing the elements of a set without actually listing out all of its members. This is especially useful for a set that has large or infinite number of elements. Set builder notation is also useful to describe an interval on the number line comprising of real numbers. Sets comprising real numbers are examples of infinite sets that are impossible to list, and thus set builder notation is absolutely necessary in such situations. So using set builder notation, we can describe elements like this: the set of all values of x, such that x is greater than 5, and x is the member of the set of integers. And so the set builder notation for this is shown: the set of all values of x, such that x is greater than 5, and x is the member of the set of integers. Another example is the set of all values greater than -2 and less than 2. So this is shown in set notation here and also on a number line. So in summary, we can describe sets in 3 ways. Firstly, we may use words. For example, the set of multiples of 2. Then, we may list out its members in brackets, as seen here. And finally, we may use set builder notation, as seen here.